Welcome to the European Parliamentary Research Service podcasts.
In this podcast, we'll talk about antimicrobial resistance and how it could be addressed thanks to new, bold approaches that could reverse the current trend. Stay with us. It's about your health.
When Alexander Fleming discovered penicillin, the first and still one of the most widely used antibiotic agents in the late 1920s, diseases and infections that carried a death sentence could finally be treated, saving millions of lives.
But antibiotics have fallen victim to their own success, and scientists and public health authorities around the world are warning that antimicrobial resistance could be the next great health crisis.
In 2019, antimicrobial-resistant infections killed nearly 1.3 million people worldwide, and this could grow to 10 million per year by 2050, becoming the second biggest cause of death after cancer. So, what are we doing about this?
Truth is, despite increasing investment in the development of new antimicrobials, awareness campaigns to prevent abuse and monitoring of antimicrobial resistance in animals, humans and the environment, antimicrobial resistance continues to grow. And the last 3 decades have not seen even one novel antimicrobial class reach the market. But could the answer lie in a Trojan horse strategy to disrupt a natural physiological process common to all bacteria?
In this case, the hidden surprise wouldn't be a Greek army led by Odysseus, but gallium, a metal very similar to iron.
Precisely because gallium resembles iron, invading bacteria, desperate to steal iron from our bodies to mount their attack, are tricked into taking it up.
Unfortunately for the bacteria, gallium doesn't function like iron once it's inside bacterial cells, and instead of helping their metabolism, it poisons and kills them. Smart, isn't it?
Definitely. But there are many other smart ideas being tested in European labs. Here's Luisa Antunes from the European Parliamentary Research Service.
Gallium is one of the several out-of-the-box ideas that scientists have developed to help tackle antimicrobial resistance. But most of these innovative antimicrobials never reach the market. This issue is known as the Translational Gap, and it's a serious issue that affects the enormous investment the EU has been doing on antimicrobial research and development, for which we need urgent answers.
A proposed solution to challenges such as this has been the creation of a European public infrastructure, equipped with its own budget, aimed at addressing long-term market and policy failures in the pharmaceutical sector throughout the whole drug life cycle. That is, from research to development, production, and final distribution.
Such infrastructure could focus on threats and areas of research that are underinvested in the current pharma business model, either due to a lack of incentives or just because they're not profitable enough.
Take multi-drug-resistant tuberculosis or cystic fibrosis-associated infections as examples. These are rare diseases for which new drugs and vaccines are urgently needed, but they affect so few people that research into them is not a priority for the pharma industry.
That's why the European Commission is addressing this challenge in its revision of the 2020 pharmaceutical strategy.
What's clear is that public and health professionals' awareness of this issue is essential to help reduce the abuse and misuse of antimicrobials. But we can do more.
According to the European Commission and the WHO, strengthening surveillance of antimicrobial use and investing in infection prevention and universal access to high-quality healthcare can also help combat the problem of antimicrobial resistance.
Want to know more? Check out Luisa Antunes' full policy brief on the EPRS website or in our app.
This is a European Parliamentary Research Service podcast.
Thanks for listening.